Hey, this is Steve. Let's learn some facts about the pressure belts of the Earth. The Earth's atmosphere is a vast and complex system, characterized by various pressure belts that play a crucial role in global weather patterns. These pressure belts are generally classified into three primary categories: the equatorial low pressure belt, the subtropical high pressure belt, and the polar high pressure belt. Each of these zones is defined by distinct weather phenomena, influencing how air moves and interacts with the planet's surface. Beginning at the equator, the equatorial low pressure belt, also known as the Intertropical Convergence Zone, ITCZ, is where warm, moist air rises due to intense solar heating. This rising air cools, leading to condensation and significant rainfall. Picture towering cumulonimbus clouds forming, releasing heavy downpours, vital for the lush tropical ecosystems below. The ITCZ migrates seasonally, which is often responsible for monsoonal weather patterns in various regions. Moving away from the equator, we encounter the subtropical high-pressure belts, which are situated around 30 degrees north and south latitude. Here, the air descends, leading to drier conditions. Envision vast expanses of desert where the sun scorches the arid landscape. This descending air is responsible for creating the world's major deserts, as it inhibits cloud formation and precipitation. The subtropical high-pressure zone is characterized by calm winds and clear skies, ideal for the formation of stable weather systems. Further toward the poles lies the polar high-pressure belt, marked by cold, dense air sinking at the poles. This cold air contributes to frigid conditions, often leading to extreme weather patterns. Imagine icy tundras, where the biting cold defines life and natural conditions. Though this region experiences generally low precipitation, occasional storms can disrupt the calm and unleash harsh winter conditions, bringing snow and chilling winds, formation of pressure belts, Earth's tilt, and uneven heating. The Earth's axis is tilted relative to the plane of its orbit around the Sun, and its spherical shape causes different parts of the Earth to receive varying amounts of solar radiation. The equator receives the most direct sunlight, while the poles receive much less, leading to uneven heating of the Earth's surface to air movement and convection cells. Warm air rises in regions where sunlight is most intense, creating low-pressure zones. Cool air sinks in regions where sunlight is less intense, creating high-pressure zones. These movements set up large convection cells in the atmosphere known as Hadley cells, Ferrel cells, and polar cells, which are responsible for the formation of the pressure belts types of convection cells on Hadley cells. Located between the equator, 0°, and the subtropical high-pressure belt, 30° N and S, in these cells, warm air rises at the equator, creating the equatorial low-pressure belt. This air then moves toward the poles, cools, and sinks at around 30° N and S, forming the subtropical high-pressure belt 2 Ferrel cells, found between 30° and 60° N and S latitudes. In these cells, air flows in the opposite direction of Hadley and polar cells. Air from the subtropical high-pressure belts moves toward the subpolar low-pressure belts, rising at around 60° N and S3 polar cells. Located between 60° and 90° N and S, in these cells, cold, dense air sinks at the poles, creating high-pressure zones. This air moves toward the subpolar low-pressure belts, where it rises again due to convergence with the warmer air from the Ferrel cells. In conclusion, the interaction between these pressure belts creates a dynamic and diverse global climate system. The rising and falling air movements orchestrate the winds, storms, and weather fronts that shape our world. Understanding these pressure belts is essential for meteorology, agricultural planning, and disaster preparedness. This knowledge helps us grasp not only our climate's current state, but also the future implications of changing atmospheric conditions due to global warming and other environmental factors. Each of these pressure zones plays its part in the grand symphony that is our Earth's atmosphere. For informative videos, please subscribe to our YouTube channel, Geography Facts.